Now we are going to solve two more problems that will involve wind speed and aeroplanes kind of problem. Will be pretty similar to what we have studied up till now, and that's not going to require any other theory as such. So let's solve one problem of that kind. Suppose there are 2 points A and B. The distance between them is L, and wind is blowing in this direction. The angle which the wind is making with this line joining A and B is theta. So wind is blowing all over the path between A and B at an angle theta with the line joining A and B. Now aeroplane, the speed of the wind is u, and aeroplane has to go straight from A to B, and the speed which aeroplane generates on its own is v. V is the speed of aeroplane that it generates on its own. U is the speed of the wind. Wind is blowing at an angle theta to the line joining A and B. The length between A and B is L. So you have to find if the aeroplane has to go straight from A to B and then come back from B to A, then what is the amount of time that it's going to take for the entire journey? Pretty good problem for concept building, and you should really spend some time with this. Okay, now I'm going to give you the answer first. So those of you who have solved it can check. This is the answer. If you have got this answer, many congratulations to you. Keep up the hard work. You are going well on the track. Now let's discuss how we'll get this. First of all, the aeroplane has to go straight from A to B. If the aeroplane attempts to go straight from A to B, it will never be able to. If the aeroplane flies straight from A to B, what would happen? There's a speed of wind which is like this. This is V and this is U. So the net resultant speed that the aeroplane eventually will have will be somewhere here. It will never be able to go straight from A to B. So what a aeroplane or the pilot should try and do is generate a speed at an angle to this line. Let's say the angle is phi. If aeroplane speeds up at an angle phi between A and B, then there's a chance of aeroplane going straight from A to B if it satisfies a certain condition, and the condition would be, see, the aeroplane will have this velocity, this v of its own, and this u would be given by the wind. Now if aeroplane has to go straight, then the net velocity should be along the line AB. For that to happen, let's break the velocity component along AB and the direction perpendicular to AB, and calling this as I cap and that direction as J cap. If you break this velocity component, it will be broken like this: V cos phi, and this would be V sin phi. If you break this velocity vector, it will be broken as V cos theta, and this would be V sin theta. So this is the component. This is U, right? This is V. This is V, and this is U. Okay. Now if the plane has to go straight from A to B, then the component of velocity perpendicular to the line AB should not exist, should be 0. So this plus this should be 0. They are in opposite direction, they must cancel each other. So numerically, V sin phi must be equal to u sine theta. This condition must exist. If the wind is blowing at an angle theta, aeroplane should have a mechanism to actually find out that angle theta of the wind and try and adjust the angle of the aeroplane to angle phi such that v sine phi is equal to u sine theta. If that happens, then the perpendicular component of the velocity would be 0 and the aeroplane will go in this direction with a velocity of v cos phi minus u cos theta. That is the net velocity in this direction. Okay, so now if that is the case, then the time taken for the aeroplane to go from A to B would be L upon speed. Speed is v cos phi minus u cos theta. This is the time for the first half of the journey from A to B, and the time for the next half of the journey would be, now again what we have to do when it is coming back, then what would happen, the aeroplane have to aim at an angle phi again such that v sine phi is equal to u sine theta. But this time the wind, the x component, the component along AB of the wind is going to support the motion and not oppose it, because the x component or the component along the line AB for both the aeroplane speed and the wind speed is going to lie along the same direction. So this time they are going to be additive. So v cos phi plus u cos theta. This is going to be the time taken for the reverse motion. And you just have to add these two and eliminate phi, because phi is the variable we have taken. It is not given in the problem. So in the answer, phi should not appear. So we will eliminate phi using this expression. It's going to be a little bit of maths and you'll get the answer as I wrote before.